Hello. So for experiment 7, which was the empirical formula for magnesium oxide, you should have gotten most of these measurements, so the mass of crucible and lid, and then the mass of all of those things plus magnesium. And from that you should be able to determine what the mass of just magnesium is by taking the mass of all of the things together and subtracting the original crucible and lid. So in this case, my mass is 0.192 grams. Then you would have cooled the things down and take the last measurement, not the average. So this is the proper weight here. So to get the mass of the product, which you would help you to get to the mass of the oxygen, you want to take the last mass and again subtract the mass of the crucible and lid. So for me that would be 0.317 grams. So to determine the mass of oxygen, you're going to take the mass of the product, which was 0.317 grams, and then subtract the starting mass of magnesium, which was 0.192 grams. And that should give you 0.125 grams of oxygen. All right, so to get to the mass ratio of magnesium to oxygen, so we're in part D again. This is mass ratio of magnesium to oxygen. You're just going to take the mass of magnesium, which was 0.192 grams, and then divide that by 0.125 grams. And that is about 1.5. And then if you take the 0.125 grams of oxygen, this is 1, so your ratio would be 1.5 to 1 or 3 to 2. All right, so that's how you would do the mass ratio of magnesium to oxide or oxygen. To get the mole ratio of magnesium to oxygen, you have to calculate the moles of each of those things. So to go from moles of magnesium to mass of magnesium, to get moles of magnesium, you need the mass of magnesium, which is 0.192 grams. And you need to convert that to moles of magnesium. And you do that with the molecular mass. For magnesium is 24.305 grams. So that comes out to 0.00790 moles. So I have 3 sig figs here, so I have 3 sig figs in my answer. The moles of oxygen will be 0.125 grams of oxygen times 1 mole of oxygen over 16.0 grams of oxygen, and that'll be 0.0078. So to do the mole ratio, (0.00790 moles over 0.0078, and that is equal to 1. So the ratio of magnesium to oxide in this case is MgO, or the mole ratio is 1 to 1, so the empirical formula will be MgO. So I jumped ahead. That one is question number 5, or calculation number 5. This is 3. Okay, so determine the percent composition. The experimental, so the percent of magnesium equals the mass of magnesium over MgO mass. That should be times 100. And that'll be 60.6%. And you'll see when you do the same calculation for oxygen, this is for magnesium, oxygen is 39.4% oxygen. And again, you have 3 significant figures here. There's 3 significant figures in the answer.